Vast Haven-1 launch, what 100,000 hours of research means for the future of commercial space. Introduction. The Vast Haven-1 project marks a significant milestone in the evolution of commercial space exploration, poised to become the world's first commercial space station. Developed by Vast, a company founded by Jed McCaleb in 2021, Haven-1 aims to create an innovative environment for microgravity research, development, and manufacturing. With a launch targeted for no earlier than 2025 in collaboration with SpaceX, this project has generated excitement within the scientific community and commercial sectors alike. Background on Vast and Haven-1. Vast was established to spearhead the development of next-generation space stations and facilitate long-term human habitation in space. The Haven-1 space station will serve as an independent platform for scientific research, offering a state-of-the-art microgravity environment for experiments and technological advancements. The station is designed to support various mission types, including private astronaut missions and government-sponsored research, thereby maximizing its operational versatility. One of the core goals of Haven-1 is to leverage over 100,000 hours of research previously conducted on the International Space Station (ISS) to inform its design and operational protocols. Research opportunities. On January 28, 2025, Vast and SpaceX issued a joint request for research proposals aimed at advancing long-term human habitation in space. This initiative is particularly significant as it invites the global scientific community to submit high-impact research projects that can utilize Haven-1's capabilities. While no direct funding will be provided to selected researchers, Vast and SpaceX will offer access to the Haven-1 lab, on-orbit crew time, and support for project design and flight qualification at no cost. This collaborative approach aims to build on the legacy of the ISS, creating new avenues for transformative research that can benefit both space exploration and life on Earth. Key research areas. The Haven-1 lab will focus on diverse areas of research, including but not limited to microgravity effects on biological systems. Understanding how microgravity affects human health and biological processes can lead to advancements in medicine and healthcare. Materials science. Studying materials in microgravity can yield new materials that may not be possible to create on Earth, potentially revolutionizing industries from construction to electronics. In space manufacturing, the ability to manufacture components in space can reduce the need for transporting materials from Earth, making space missions more sustainable. Commercial and government missions. Haven-1 will cater to a wide range of mission types. 1. Private astronaut missions. Vast plans to offer opportunities for private individuals to experience space travel, broadening public interest in space exploration. 2. Government missions. Collaborations with government agencies for scientific research and technology demonstration will be a cornerstone of Haven-1's mission profile. 3. Payload missions. The station will host payloads for various scientific experiments, contributing to a diverse array of research initiatives. The versatility of Haven-1 is expected to attract both commercial partners and governmental entities, ensuring a steady stream of missions and research opportunities. Technological innovations. Vast's vision extends beyond Haven-1 with plans for Haven-2, a proposed successor to the ISS. Haven-2 is designed to include capabilities for artificial gravity habitation, reflecting Vast's commitment to creating sustainable environments for human life in space. Features of Haven-1. Habitable volume. The station will offer a habitable volume of 45 cubic meters, accommodating crew members and researchers. Power supply, with a power capacity of 13,200 watts. Haven-1 will support various scientific instruments and living amenities. Observation window. A large domed window will provide stunning views of Earth, enhancing the experience for astronauts and researchers. Partnership with SpaceX. The collaboration between Vast and SpaceX is crucial to the success of Haven-1. SpaceX will utilize its reliable Falcon 9 rocket and Dragon spacecraft for the launch and transportation of crew to the station. The partnership capitalizes on SpaceX's extensive experience in crewed missions and reusable spacecraft technology, ensuring a robust foundation for Haven-1's operations. Launch timeline and future missions. 2021, VAST founded by Jed McCaleb, setting the stage for commercial space stations. 2024, collaboration with SpaceX announced establishing a pathway for Haven-1's launch. January 28, 2025, joint request for research proposals issued, marking a pivotal step in integrating the scientific community into upcoming missions. 2025, scheduled launch of Haven-1 followed by the first crewed mission. VAST-1. Conclusion. The VAST Haven-1 initiative represents a transformative moment in commercial space exploration, aiming to create a sustainable human presence in orbit while opening new avenues for scientific research and technological innovation. By harnessing the lessons learned from over 100,000 hours of research and development, VAST and SpaceX are poised to redefine humanity's relationship with space. This collaborative effort not only enhances our capabilities in space but also seeks to address challenges on Earth, emphasizing a dual benefit for humanity. As we look toward the future, the launch of Haven-1 stands as a testament to the potential of commercial space endeavors and the limitless possibilities that await in the cosmos. The VAST Haven-1 launch set for 2025 is a significant advancement in commercial space as it aims to be the first commercial space station. However, several counterintuitive aspects emerge from the information surrounding this initiative. 1. Commercial space stations as research hubs. While space stations have traditionally been associated with government-funded missions like the ISS, VAST Haven-1 is positioning itself as a commercial entity available for scientific research without direct funding. This is counterintuitive, as one might expect commercial ventures to demand payment for access. Instead, VAST offers a platform for researchers to conduct microgravity experiments at no cost for project design and flight qualifications, potentially undercutting traditional funding models in scientific research that rely on grants and institutional budgets. 2. Public versus private space exploration. The partnership between VAST and SpaceX represents a shift where private companies are taking on roles traditionally held by government agencies. This collaboration aims to open up space exploration and habitation to private astronauts and commercial missions, which could lead to a more democratized approach to space travel. The notion that private companies can facilitate research and exploration in ways that government entities have not fully capitalized on is an unexpected turn in the narrative of space exploration. 3. Artificial gravity ambitions. VAST's long-term goal includes developing artificial gravity habitats, a concept traditionally relegated to speculative science fiction. The ambition to create environments where gravity can be simulated challenges the established understanding of space habitation, which has typically focused on microgravity conditions. This could redefine how long-term human life in space is conceived, suggesting that sustained human presence might not only survive in microgravity but could thrive in environments mimicking Earth's gravity. 4. The role of SpaceX. SpaceX's involvement is often viewed in the context of its rocket launch capabilities, but in the context of the Haven-1 initiative, it also positions itself as a facilitator of scientific research. The expectation that a launch company focuses solely on transport is challenged by its role in advancing scientific missions and providing infrastructure for research, thereby blurring the lines between space transportation and scientific exploration. 5. Incentives for research. The request for research proposals from the global scientific community by VAST and SpaceX, which does not include direct funding, challenges conventional funding expectations. This could potentially lead to innovative research ideas that are unencumbered by financial constraints, allowing for a broader range of experimental designs that might not typically be funded under traditional grant systems. The notion that researchers would pursue opportunities in an environment without guaranteed financial return is an interesting deviation from standard practices. 6. Environmental considerations and regulatory challenges. SpaceX's ongoing challenges with environmental regulations and the licensing process provoke a counterintuitive discussion around safety and innovation. although SpaceX has made significant advancements in rocket recovery and reusability. The regulatory environment seems to lag behind technological progress. This contradiction highlights the tension between rapid innovation and regulatory frameworks that often struggle to keep pace with new developments in aerospace technology. 7. Commercial space as a solution for earthly problems. The potential for research conducted on Haven-1 to translate into solutions for challenges on Earth is a surprising angle. The idea that commercial space stations can not only advance space exploration but also contribute to solving terrestrial issues is a shift from viewing space as a separate domain from Earth's problems. This integrated approach could lead to a re-evaluation of how investments in space technology are justified in terms of their practical benefits for life on Earth. These counterintuitive elements reflect a transformative period in the space industry where traditional paradigms are being challenged and new opportunities are emerging that could reshape our understanding of space exploration commercial viability and scientific research. The vast Haven-1 launch marks a significant milestone in commercial space exploration, yet several critical aspects of the initiative are likely to be overlooked by the general public. Here are some important content elements that deserve further attention along with explanations of their significance. 1. Research collaboration opportunities. The joint request for research proposals from VAST and SpaceX is a pivotal moment for scientific collaboration in space. This initiative allows researchers from around the world to access microgravity environments without the burden of funding for project design and flight qualifications. While many may view this as just another research opportunity, the significance lies in the democratization of space research and the potential for breakthroughs that could arise from diverse global collaborations. This open access can lead to innovative solutions to complex problems both in space exploration and terrestrial challenges such as health issues, materials science, and environmental sustainability. 2. Commercial and government missions. Haven-1 is designed to host a variety of missions, including private astronaut missions and government payload missions, making it a versatile platform for different stakeholders. This multi-mission capability is significant because it represents a shift in how space can be utilized. Traditionally, space exploration has been dominated by government entities and large institutions. By broadening the scope to include commercial partners, VAST and SpaceX are paving the way for a new era of space utilization that can spur economic growth, create new business models, and enhance scientific discovery. 3. Technological innovations and future vision. VAST's long-term ambition to develop Haven-2, a proposed successor to the ISS that aims to enable artificial gravity habitation, is an ambitious goal that goes beyond simple habitation in space. This vision is crucial for the future of long-term human presence in space, as artificial gravity could mitigate many health issues associated with prolonged exposure to microgravity. While the idea of artificial gravity may sound like science fiction, the underlying research and technological advancements required to achieve this could lead to significant innovations in engineering, materials science, and human physiology. 4. The role of microgravity in scientific research. The emphasis on microgravity environments for advancing scientific research is often taken for granted. However, research conducted in microgravity has the potential to reveal fundamental insights into physical sciences that are impossible to observe on Earth. For example, studies on fluid dynamics, combustion, and material formation can lead to the development of new technologies and processes that have applications both in space and on Earth. The ability to conduct such research in a dedicated commercial space station will accelerate the pace of discovery and innovation. 5. SpaceX's proven track record. The partnership between VAST and SpaceX is grounded in SpaceX's established history of successful missions and technological innovation. Public discussions about space exploration often focus on new entrants, but the importance of working with an experienced partner cannot be overstated. SpaceX's expertise in reusable rocket technology and crewed missions reduces risk and enhances the likelihood of success for Haven-1. This collaboration highlights the importance of leveraging established capabilities in new ventures, which could serve as a model for future commercial space initiatives. 6. Impact on global space policy. The launch of Haven-1 could have broader implications for global space policy and governance. As commercial entities become more involved in space exploration, discussions around regulation, collaboration, and international treaties will need to evolve. The public may not fully grasp how initiatives like VAST's Haven-1 can shape future space laws and agreements, particularly in terms of resource utilization, jurisdiction, and sustainability in space. 7. Human spaceflight as a driver for STEM. The potential for private astronaut missions to Haven-1 can serve as a powerful driver for interest in STEM, science, technology, engineering, and mathematics fields among the general public. The allure of space travel, particularly in a commercial context, can inspire the next generation of scientists, engineers, and explorers. Overlooked is the broader societal impact that such missions can have on educational initiatives and workforce development in sectors critical to space exploration and technology advancement. 8. Health and safety in space exploration. The emphasis on addressing health challenges associated with space travel is critical but often overlooked. As VAST and SpaceX develop platforms for long-duration missions, the importance of studying and addressing health issues such as radiation exposure and the effects of microgravity on human physiology cannot be understated. The research facilitated by Haven-1 could lead to enhanced safety protocols and health countermeasures that will be essential for longer missions such as those to Mars. 9. Sustainability and environmental considerations. Discussions about space exploration typically focus on technological advancements and economic benefits, yet the environmental impact of such initiatives is rarely highlighted. As commercial space stations emerge, the need for sustainable practices in space operations becomes paramount. VAST's commitment to sustainable environments for humans in space may provide a framework for addressing these concerns, which can ultimately influence policies and practices both in space and on Earth. In conclusion, the VAST Haven-1 launch is a multifaceted initiative that extends beyond the immediate excitement of commercial spaceflight. Recognizing the overlooked elements, such as research collaboration opportunities, the evolution of commercial and government missions, and implications for global space policy, can provide a deeper understanding of the significant potential this project holds for the future of humanity in space and the benefits it may yield for life on Earth. Here are the 4 most valuable points for in-depth analysis and discussion regarding the VAST Haven-1 launch and its implications for the future of commercial space. 1. Research opportunities and microgravity utilization. The VAST Haven-1 marks a significant advancement in the realm of microgravity research and in-space manufacturing. With its capabilities to facilitate various types of scientific research, including those that leverage microgravity environments, Haven-1 has the potential to create groundbreaking discoveries that can benefit both space exploration and life on Earth. The collaborative request for research proposals from VAST and SpaceX emphasizes the commitment to integrating the global scientific community into their missions. This approach allows researchers to access unique microgravity environments at no cost, albeit without direct funding, which could lead to innovative solutions to pressing challenges in health, materials science, and technology development. The implications of such research extend beyond space, potentially providing solutions to problems faced on Earth. 2. Commercial and government missions flexibility. Haven-1's design accommodates various mission types, including private astronaut missions, government-led projects, and scientific payload missions. This versatility is crucial for attracting a diverse range of partners, from commercial entities looking to conduct research in space to government agencies aiming for experimental and exploratory missions. By catering to both commercial and governmental needs, VAST not only enhances the operational viability of Haven-1 but also positions itself as a key player in the evolving landscape of commercial spaceflight. This multifaceted approach can lead to more sustainable operations and promote a thriving ecosystem in low Earth orbit LEO. 3. technological innovations in future space habitats. VAST's vision for Haven-1 includes the development of Haven-2, a proposed successor to the International Space Station ISS, which aims to enable artificial gravity habitation. This ambition reflects a broader commitment to creating sustainable environments for humans in space. The pursuit of artificial gravity is particularly significant as it addresses one of the major challenges of long-term human habitation in space, mitigating the adverse effects of prolonged exposure to microgravity on human health. If successful, this technological innovation could pave the way for a new era of space stations that can support long-term missions, including those aimed at Mars and beyond, fundamentally changing how humanity interacts with space. 4. Partnerships and the role of SpaceX. The collaboration between VAST and SpaceX is a cornerstone of the Haven-1 initiative. SpaceX's expertise in reliable launch services, demonstrated through its Falcon 9 rocket and Dragon spacecraft, provides a strong operational backbone for VAST's ambitions. This partnership not only ensures the successful launch and operational capabilities of Haven-1 but also exemplifies the broader trend of public-private partnerships in space exploration. As commercial entities like VAST enter the space ecosystem, the reliance on established aerospace companies such as SpaceX highlights the importance of collaborative efforts in advancing space exploration technology and infrastructure. This relationship could serve as a model for future endeavors in commercial spaceflight, illustrating how innovative partnerships can accelerate progress and reduce costs. These points encapsulate the potential of the VAST Haven-1 launch to reshape commercial space, emphasizing scientific research, versatile mission capabilities, technological advancements, and the importance of strategic partnerships in fostering a sustainable human presence in orbit. Here are 3 famous historical cases that share similarities with the VAST Haven-1 launch and its implications for the future of commercial space. 1. Skylab 1973–1974. Skylab was the United States' first space station, launched in 1973. It was designed to serve as a microgravity research laboratory and hosted a variety of scientific experiments. Skylab's missions were pivotal in demonstrating the feasibility of long-duration human habitation in space. The research conducted during its operation provided valuable insights into the effects of microgravity on human physiology and advanced scientific knowledge in various fields, including solar astronomy and materials science. The legacy of Skylab laid the groundwork for future space stations, including the International Space Station ISS, and exemplifies the importance of commercial and governmental collaboration in space research. 2. Mir Space Station 1986–2001. The Mir space station, operated by the Soviet Union and later Russia, was one of the most significant achievements in human spaceflight. It was a modular space station that hosted numerous international crews and served as a platform for scientific research, technology development, and international collaboration in space exploration. Mir was instrumental in advancing our understanding of long-term human presence in space, hosting experiments in various scientific fields. Its operations demonstrated the benefits of commercial partnerships as companies began to conduct research aboard Mir, paving the way for future commercial endeavors in low Earth orbit, much like the VAST Haven-1 initiative aims to do. 3. International Space Station ISS 1998–present. The ISS is a landmark example of international collaboration in space exploration. Launched in 1998, it serves as a microgravity research laboratory and has facilitated experiments across multiple disciplines, including biology, physics, and materials science. The ISS has hosted astronauts from various countries and commercial partners, enabling private companies to conduct research and develop technologies in space. The collaboration between government space agencies and private entities on the ISS illustrates the potential for commercial space endeavors to benefit humanity, much like the goals of the VAST Haven-1 project, which seeks to foster research and innovation in microgravity. These historical cases highlight the evolution of human spaceflight and the role of commercial partnerships in advancing scientific research and technology development in space. Future outlook. Predictions for the future of commercial space post VAST Haven-1 launch. The anticipated launch of VAST's Haven-1 represents a significant milestone in the evolution of commercial space exploration and habitation. As the world's first commercial space station, it is set to open new avenues for scientific research, technological advancement, and commercial opportunities in low Earth orbit (LEO). The implications of this launch extend far beyond its immediate operational goals, potentially reshaping the future of humanity's presence in space. 1. Expansion of commercial space operations. The successful deployment of Haven-1 in 2025 is likely to catalyze a surge in commercial space operations. As companies recognize the viability of sustainable business models in orbit, we can expect a proliferation of private space stations, research facilities, and tourism ventures. This trend will not only democratize access to space but also stimulate innovation in space technologies, logistics, and habitation solutions. 2. Enhanced scientific research and technological development. Haven-1's microgravity environment will offer unprecedented opportunities for scientific research and technological development. The insights gained from experiments conducted in microgravity could lead to breakthroughs in various fields, including medicine, materials science, and environmental sustainability. The ability to conduct long-duration experiments in a commercial setting may attract a wider array of research proposals from academia and industry, fostering unprecedented collaboration and knowledge exchange. 3. The rise of in-space manufacturing. With the increasing capabilities of commercial space stations like Haven-1, in-space manufacturing is poised to become a thriving industry. The advantages of producing goods in microgravity, such as improved material properties and reduced production costs, will likely lead to the development of specialized manufacturing facilities in orbit. This shift may also reduce dependency on Earth for certain materials and products, paving the way for a more self-sufficient space economy. 4. Advancements in space tourism. The partnership between VAST and SpaceX is expected to pave the way for space tourism. As Haven-1 caters to private astronaut missions, the experience of traveling to a commercial space station will likely become a reality for affluent individuals and researchers alike. The growth of space tourism will not only generate revenue but also inspire a new generation of explorers, scientists, and engineers, thereby expanding public interest in space exploration. 5. Development of artificial gravity solutions. VAST's vision for Haven-2. A successor to the ISS designed to enable artificial gravity habitation, reflects the increasing focus on long-term human habitation in space. As the technology for creating artificial gravity matures, it could revolutionize the way humans live and work in space, addressing challenges related to prolonged exposure to microgravity such as muscle atrophy and bone density loss. This development will be crucial for future long-duration missions to Mars and beyond. 6. International collaboration in space exploration. The success of commercial initiatives like Haven-1 could foster greater international collaboration in space exploration. As more countries look to establish their presence in LEO, partnerships between commercial companies and governmental agencies may become increasingly common. Such collaborations could lead to shared research initiatives, joint missions, and a unified approach to tackling the challenges of space exploration and habitation. 7. Regulatory and safety frameworks. As commercial space activities expand, there will be an urgent need for robust regulatory frameworks to ensure safety and sustainability. The lessons learned from the launch of Haven-1 and subsequent missions will inform the development of regulations governing space traffic, debris management, and environmental protection in orbit. Effective governance will be essential to mitigate risks and promote responsible practices in the burgeoning commercial space sector. 8. Economic opportunities beyond Earth. The commercial space landscape will likely create economic opportunities that transcend Earth's boundaries. As in-space research, manufacturing, and tourism gain traction, new markets and job opportunities in space-related industries will emerge. This shift could lead to a new economic paradigm where space becomes a key driver of global economic growth, innovation, and job creation. 9. Long-term human presence on other celestial bodies. The advancements stemming from Haven-1 and its successors may lay the groundwork for humanity's long-term presence on other celestial bodies, particularly Mars. The technology developed for life support, habitat construction, and resource utilization in LEO will directly inform future missions to establish human colonies on Mars. As the journey to becoming a multiplanetary species gains momentum, the experiences learned from commercial space stations will be invaluable. Conclusion. The vast Haven-1 launch is a pivotal moment in the commercial space sector, heralding a new era of exploration, innovation, and human presence in space. As we look to the future, the integration of commercial entities, scientific research, and international collaboration will be essential in transforming the possibilities of space exploration into reality. The potential benefits for humanity are immense, suggesting a future where space is not just a destination, but an integral part of our economic and social fabric.